Welcome everyone to our next session, which is with 4 experts who are going to be talking about some of the issues that we need to be aware of when using blockchain. I do want to thank both the School of Information at San Jose State University and the Institute for Museum and Library Services for sponsoring this event as we all learn more about blockchain, what it means, how it can be used, different applications, and different issues that we need to be consider for it. As Sandy mentioned in the first session, I'll just go over it very quickly in case you missed it. But in addition to today's mini conference, all of the sessions are going to be recorded and they are available later on for you to view. We're also going to have a blockchain national forum that will be live streamed. It's free. It will be on Monday, August 6th from 9 a.m. to 5 p.m. And this information is on our website that's at the bottom of the screen, ischoolblogs.sjsu.edu/blockchains. Sandy Hirsch and I, who are the co-PIs on the IMLS grant for blockchain recommendations, are going to be giving a webinar on September 24th that is available at ALA, and it is free. And we're also going to be doing a book that is part of the Library Future series. It will be low cost, giving explanations of blockchain and examples of how it's being used. So those are some things for you to be looking toward in the next few months. Here are some pictures of our presenters today, and our format is going to be that they will present their information at the beginning and we'll hold all questions to the end. So each person is going to be giving about a 10-minute presentation in order to have time to interact with them. So let me take a few minutes to introduce our speakers today and to thank them so much for joining us. First is Todd Carpenter, who is the Executive Director of NISO, which is National Information Standards Organization. Todd is a graduate of Syracuse and Johns Hopkins University, and he is editor of a book, The Critical Component, Standards in the Information Exchange Environment. He is an active contributor to the Scholarly Kitchen blog and writes a regular standards column in Against the Grain. He is very active in many professional associations, including ISO's Technical Subcommittee on Identification and Description, the Board of the Foundation for Baltimore County Public Library, Linked Content Coalition, and the Free eBook Foundation, as well as other activities. So we are happy to have him join us talking about standards. Dan Blackaby is going to be talking about legal issues involved with blockchain. He is the head of technology initiatives at Cornell University Law School. He's worked as a professional librarian in various roles, including research, technology, cataloging, and acquisitions, and he holds several degrees from the University of Houston, Michigan State University, San Jose State University, and California State University at Fullerton. Dan has a rich background in law librarianship and has worked in many different library settings, including the Montana Department of Natural Resources, Microsoft, the Santa Clara County Council, South Texas College of Law, and the Western State College of Law. And in recent years, he's been invited to speak at national forums on topics ranging from digital repositories to blockchain technology. Tonia and Nicolas-Rocca is on the faculty at the School of Information at San Jose State University. She received her PhD in Information Systems and Technology from Claremont Graduate University, and her research interests include cybersecurity, health information systems, and knowledge management. Dr. Stan Nicolas-Rocca has published her work in numerous peer-reviewed research journals and conference proceedings. In addition to teaching, she has many years of experience in industry in the analysis, design, implementation, and strategic use of wide area networking and security within multinational organizations. And our final panelist is Michael Della, who is the Director of Technology at the Digital Public Library of America. Prior to joining DPLA, Michael worked in software development, publications, and in the startup, library, and education spaces for nearly 2 decades. Most recently, he worked as the engineering manager at the content marketing company Scribble Live. And prior to that, Michael worked as a developer and architect on the repository and digital gallery teams at the New York Public Library and built content management, online learning, and semantic metadata applications at Columbia University. He is a graduate of Bates College. So you can see that we have 4 individuals who are highly skilled in technology and in their areas of expertise in standards, law, cybersecurity, and other technology with DPLA. So we're very thrilled to have them join us, and I am going to turn it over to Todd Carpenter from NISO. So please take the mic and get started.
Okay, great. Thank you so much, Sue. I presume you can hear me. One of the great joys of following Jason Griffey is when you have 10 minutes to speak, he's already covered a good number of the topics. So I'm going to dig into a little bit more detail than Jason. Like Jason, I am kind of a geek, and I do like to spend some time in the technical weeds, although I promise I won't start talking in angle brackets for all of you. I'm going to start with a paper that IEEE, the International Association for Electrical Engineers, released. They're a standard-setting body. They released this white paper in November of last year. And this is a culmination of a symposium that they hosted in October, looking at the state of issues and state of technology around blockchain and some of the issues that it raised. Now, the first issue amongst standards is basic terminology. And blockchain, as Jason mentioned, it covers a wide range of technologies, everything from distributed computing, cryptography, even game theory. And some of these things have been applied in a variety of blockchain systems, but not everything and not in every system. So the real question, one of the real questions, is what is a blockchain? What qualifies as a blockchain, and what are the definitions of the various components that comprise a blockchain, and how do we function within those? Now, with a variety of systems developing simultaneously, as Jason mentioned, some of those overlap, and some of them are trying to address similar problems. And either we enter a situation where we need to agree on a single solution, which is unfortunately unlikely. We often need to explore how those differing systems need to interoperate and then avoid the situation of silos. The white paper went on to describe 3 things that we need. The first is a paradigm for evaluating design, or basically how do we make this stuff work. Another element is this, the number 3 in this list is how do we understand this technology better? And then the second element, which I'm going to dig into a bit more detail, is a strategy for adopting technical standards for how these systems function. Now, as Jason mentioned, there's a variety of applications, and throughout the rest of the afternoon, you'll hear in much more detail some of the applications and uses. I'm not going to go into any detail about 2, but I want to highlight 2, and then use those as just simply case studies for where standards in our community need to be applied. So, as Jason mentioned, identity is one of these. If you're going to securely circulate content to a community, you need to know and manage who is in that community, who isn't, and this is a very messy business. Blockchain obviously provides opportunities there. Another issue, again, something that Jason mentioned, is supply chain. Libraries in the business of circulating content, acquiring that content, sharing it, receiving it, processing it, retrieving it, recirculating is something that blockchain is quite well suited for. And a third application has to do with the supply chain of copyright and the notion of exchanging the rights, especially as copyright is now extended for 100+ years. We need clear rights management tracking in order to facilitate reuse. And again, as I said, not going into any of these in detail, but I want to use those as highlights for this, which is what I think to be, from my perspective, the key areas where operational and functional areas that we need to consider for standards. Now, some of these elements are functional as far as how the blockchain system will work and how it gets set up. So process management and data retention are elements of the functional side of keeping blockchain moving. Others in this list are focused on what the system does, what we want it to do, and how we describe what our goals are or use cases, and how we design the system around facilitating those use cases. So the first element of this, as I describe it, process management. Basically the nuts and bolts of the system, how the systems work. What sort of algorithms are we going to use? How do we ensure that people are using those algorithms in the appropriate way? What metadata do we want to collect? Obviously, this depends on the transactions that we're trying to track. But, you know, there's a variety of depth of data when it comes to metadata, the granularity, et cetera, et cetera. What type of data exchange do we need across systems? So what sort of interoperability, and how do we make those systems, those various systems, interoperable? What are the data availability rules? Now, within a blockchain system, there is public information and there's also private information. How do we decide what to be made public and what to retain in private? How do we correct errors in the system? Say, you know, obviously this blockchain is renowned for its stability and maintaining information, but say in copyright, for example, how do we deal with a rights situation when a name is either inadvertently dismissed or someone is added later as an additional author? How do we deal with those sort of situations? And then there's compliance issues with privacy regulations, such as HIPAA and FERPA. Just because we're sharing some of this information, are we allowed to? Moving on to the next question of state changes. Blockchain is really good at tracking this move from owner A to owner B, such as a piece of art or a Bitcoin. And the real question here is, what defines a state? What does it mean to have a paper published? What's a publication date? Is it the first day it was made available online? Is it the date the author first put pen to a word processor? These things are kind of messy. And how we deal with those things is often the challenge. Who determines when an object is passed from one state to another? Or alternatively, what is the timing appropriate for tracking these state changes? In circulation systems, you might want to know whether something is on the shelf right now. Does it make sense to update your system on a kind of immediate basis, or is daily, weekly, etc. sufficient for your needs? Provenance is another question that Jason had mentioned. How do we establish a current state when we're implementing a blockchain system? In the museum space, the Elgin marbles are in the British Museum, but the Greeks have a very different notion about who owns them. So how do we establish that certainty state at the beginning? And then how do you develop rules around transfer from one person to another or one entity to another? Importantly, how do you ensure every transfer is taking place in the system? Say, again, with interlibrary loan, what happens when something gets sent out, doesn't actually arrive at its end destination, but eventually comes back? How do you note that in the system because one element of this chain has been lost? And then how do we ensure the validity of the people who are submitting the data? How do I know who you are? How do I know who you say you are? And how can I trust who you are? In Bitcoin, that might not be necessary, but certain library applications, it certainly would be. And digital authenticity is another area here, particularly digital authenticity, as Jason had been discussing it. How do we handle when situations are taking place in transfers between systems with different practices? How do you control creating records in a system and ensure that that is validated? How do you return an object that might have been altered in some way? How do you return to that object's original state? And then finally, retention. By retention, I mean blockchain systems are ever-expanding systems. They grow and grow and grow. At what point do we run into scale management issues, and how do we de-ascension data? What type of data management rules and processes do we have to put in place? And then finally, as someone had mentioned in the Q&A with regard to GDPR, what about the right to be forgotten? How do we do with that? And really one of the big issues, as with all metadata systems, as with all tracking systems, really comes down to a core question about the cost of managing that system over time and at scale, and whether or not that is really worth the investment necessary to put those things together. So with that, I know Jason ended with the hype clause. I think we're entering in a kind of phase where we're kind of getting down into the weeds. And we have to get down into the weeds in order for some of these systems to reach broad application. And a lot of those weeds are, of course, standards. So just as a baseline for some conversations that I think we can have as we move forward. So with that, I'm going to pass it on to our next speaker. So thank you very much.
Thank you, Todd. This is Dan Blackaby, and I'm going to talk about the legal concerns. Is it okay if I go ahead, Sue?
Yeah, go ahead.
Okay. I only have one slide to show everybody. And the reason I only have one is mainly because law and the technology are moving at such a rapid pace. I'm not sure if I gave you any definitive information on a slide today that it would be correct tomorrow. So I'm going to approach this more from the questions that I think we have to ask as we move forward. While my title where I work is Head of Technology Initiatives, I'm going to approach this from the other end of my job, which is teaching legal research and how we determine what law applies to any specific or given situation. There have been numerous books and white papers about this topic, and few really offer concrete solutions, mainly because it's simply too early in the life of the technology for any kind of consensus on the right way to integrate or apply existing law to blockchain. In other words, we're still feeling our way around in the dark. We will inevitably need new laws and changes to old laws, but most of the resources you'll see on the legal status of blockchain are going to be descriptive rather than prescriptive. You don't see a lot of people taking positions yet on what the law should be, mainly because it hasn't filtered down as to what the actual lay of the land is yet. At the end of my time, I'll give you a reference to what I think is the best attempt at that so far. First off, I want you to think about what Todd said, in that there is no one type of blockchain. It's not a static thing, but rather a tool. And we need to be careful about talking about it in terms of application rather than as a static entity. I like to think of it like Eric Clapton. It's in the way that you use it as to what it really is. They can be both centralized and decentralized ledgers. They can be public or private, permissioned or open blockchain, and use various methods of deriving consensus to come about the next action of the blockchain. And for legal purposes, one of the most exciting things is they can have integrated smart contracts. But we should refrain from concentrating on what they are and look more at what they can do. To say that fitting blockchain into laws like fitting a square peg into a round hole is a little disingenuous. I think of it more as trying to coat an electrified barbed wire fence with melted marshmallows. Basically, it's messy, it's incomplete, it's painful, and for lawyers, it doesn't smell right. Just how the fence makers really designed it in this case, because blockchain as itself was designed to be extra legal, as in designed without concern for the legal context, more toward what it can do. And so we have to catch up to it, just as we are trying to catch up to the internet itself. One of the first questions you can ask, and this is the first legal concern I have listed, is jurisdiction. A good example of this is online gambling. With online gambling, inevitably we went back to going, where is the server? We established it by establishing physical jurisdiction. But if you, say, put a betting line into a blockchain, not only would you have the automatic notification of who won, who lost, who gets the money, how it's distributed, but establishing exactly where this event took place would be almost impossible, because where is the blockchain? And also, who owns it? Who is the who when it comes to the blockchain if everyone has a copy on their copy of the distributed ledger? It makes it almost impossible. It's not cloud storage in the traditional sense where Google or Facebook have made us click through all the boilerplate language saying that they actually own the stuff. And it sits on no one computer or server, so it doesn't really exist anywhere. Then there's also the issue of autonomy. Now that might not mean anything out of context, but for a lawyer, when it comes, especially when it comes to contractual actions and engagement, autonomy is very important, because there are elements to a contract that your normal smart contract just doesn't hear. And that's, you have to have two parties, you have to have a meeting of the minds, you have to have a number of things that go into a contract rather than just the executable, which is what, if it's sometimes you see it termed as a Ricardian contract, where it's just the action, which is normally what you're going to see into a smart contract in a blockchain context. Basically, it transfers the legal process into an automated self-functioning event, one that can reference outside third parties or an arbitrator or something else that determines the facts of the case in each context. Probably the simplest example is a vending machine. You have an implied contract when you go to a vending machine, and when you put the rumpled dollar into the vending machine, that you're going to get a Coke in return, or whatever you want. So for every contract, there are multiple parties and actions. There's you who wants the Coke at the end. There's the owner of the vending machine. There's the owner of the location where the vending machine is. But as Todd stated before when he was discussing changes in state, what happens if you want your money back? What happens if the Coke doesn't dispense? There's what you call recourse methods that you have to have built into a contract that a blockchain really hasn't dealt with how they're going to attack that. Because if you think about the append rather than delete nature of a blockchain, it's about going forward. If you say, I want to go back and change this, they really haven't examined how they're going to do that yet. And think about the contract that most people have. That's their lease. If your landlord decides they want to give you a break on your rent, they can do that regardless of what the lease actually says. Just as if you don't feel like you have to call to your landlord when you need to fix something, you can do it yourself. That is incorporated into the lease. But that kind of flexibility isn't really part of smart contract and smart contract litigation that we've seen so far. It's more about predetermined actions that you set in place and wait for it to happen. A good example of that would be your Easy Pass. if any of you drive on toll roads. It automatically will charge you. It will automatically renew on a monthly basis, and you have to actively go in and change it. That is one of the things I've seen be discussed about putting into a blockchain, is those kinds of transactions that will automatically debit accounts, that will automatically renew and take the action of renewing your interest in either your EasyPass, your magazine subscription, anything like that. So it's one of the main drivers behind stepping back from blockchain as a be-all, end-all smart contract solution. The third concern that I've listed on this slide is banks. Banks have begun using blockchain for post-trade clearing and settlement. Basically, once there's a trade, it will settle who owes what money, what accounts they come from. The kind of appending nature of a blockchain really leads to an audible trail of transactions so that trades can be reconciled and there will be no dispute as to who made what trade when. But the more you automate these processes, the more difficult it is to implement the flexibility you need at the margins so that your bank doesn't foreclose on your delinquent mortgage just automatically, and that it gives them the ability to be differential. That's something that we've grown used to in society that may not be aided by the blockchain. And if you think about it, the more trades get used to in the blockchain, you're going to have things like identity verification and syndicated loans put into a blockchain. So if you package mortgages into a blockchain, think about what happened with the 2008 crisis. You're going to have, it was difficult enough then to tell what was valued and who had what. Now, trying to retract it would be even more difficult. Blockchain can also function, as we've seen with Bitcoin, as a payments and remittance system, as you've seen before. But probably the primary thing that you're going to see is as a land registry. I see a question in the chat about blockchain lasting past a person's lifetime. That's what land registries do now. The things that record who owns your property, who owned the property 3 people before you. That kind of deed in the registry is something the blockchain will function well for. But the question with banks is really, do they meet current banking standards and notifications? So we'll have things like, start with the last, how am I going to say this? The capitalization requirements for banks. They have to have a certain amount of money before they can issue loans, before they can make trades. What happens when that capitalization is in Bitcoin? Because as we've all seen in the last year, Bitcoin's valuation is not easy to ascribe. It's very difficult to know who owns the blockchain and what happens to that money afterwards, and when is that value going to happen. How do you put it on a balance sheet, basically? Then, as Todd also mentioned, the GDPR, the thing that happened a few weeks ago where you suddenly got notifications about privacy changes and all sorts of changes in cookies on your websites. The main difficulty we're going to have there is that the GDPR has very specific requirements for data providers in reference to data users. It's not clear how that's going to shake out. The right to be forgotten doesn't really play with the blockchain very well. But on the other end of the regulatory spectrum, you're going to have things like anti-money laundering laws. So you're going to have things like KYC, which is know your customer, and CDD, which is customer due diligence. They have to know who they are for each particular element of the transaction. So if they have the right to be forgotten, but the money laundering statutes say you have to know who they are, how does that play together? And it doesn't really have we don't really have an answer yet. But let's think about it back to the digital copyright issue that we were talking about earlier with Todd. If there is that copyright notification, if it's in the blockchain, if the blockchain itself is violating copyright, some of you may have seen the Financial Times in the last few years has something called CryptoKitties art installed into the blockchain. So if that art is in the blockchain itself violates copyrights, who gets the digital copyright violation notification? That's unclear. And you may have seen back in December there was a notification about people finding pornographic images in the data storage aspect of the blockchain and being afraid that it was imputed to them that they have pornography on their blockchain, on their computers. And the truth is they do, but it's not going to be, the law is not going to handle it that way. Those are all issues that the law has to deal with. My main thing is that it's a tool, and it shouldn't be seen as solving everything. There's a danger that it becomes what the Financial Times called a belief system when it comes to the fact that it would solve everything. I think just the questions I may have asked today might show you that we don't have enough answers yet for it to be that stable going forward on being sure where you're going to be on each issue. The law will adjust to it, though. It has for almost every other element of technology change that we've had in the past. It may be slow, as we may be seeing with freedom of the internet and data throttling, but it will catch up. And it will, once we have laws that are being made in anticipation of blockchain technology and with it in mind, then things will settle out. But in the meantime, you're going to have problems like the GDPR or data localization laws like you have in China. So I think that's what I have for today. I'll hand it off to our next speaker. Is that Tonia?
It is, and thank you so much, Dan. I'll turn it over to Tonia. Thank you, Dan.
Yes, thanks, Dan. Hello, everyone. My name is Tonia, and wow, there's been a lot of excellent information shared today about blockchain technology, and it's all very exciting. For my talk today, I will be speaking about really the security side of blockchain, and of course everybody is really talking about some of the security involved and some of the issues and all that. And we must understand that blockchain is obviously evolving. It's a very young technology, and therefore it's, you know, we can't be fixed on definitions, and we can't be fixed on you know what's it doing today, what it is doing today versus what it can be doing in the future. So again, it's very important to keep that in mind. Move on to the next slide. Oh, thanks. So let's get into what blockchain is. And again, this is not a fixed definition. It's really a combination of the different types of the different definitions that are out in the literature and that are available on different industry websites. And so blockchain is a secure digital ledger of chronological timestamp transactions that is shared across and verified by its users. Each transaction is recorded, timestamped, and added to a block. And of course, the block in itself is then encrypted. Now, of course, this process continues for every transaction, creating this chain of blocks. So, you know, in understanding the transactions are tracked in this ledger system, and the ledger system then is going to be called the blockchain. And so multiple copies of this ledger will exist and are constantly compared to each other. Remember, there's numerous systems in place here, and so the ledger is then going to be stored on, you know, multiple devices, and therefore the ledger will constantly be compared to each other to ensure that all transactions are legitimate and properly recorded. As Dan had mentioned, there are different types of deployment models, but again, we can't be fixed on them. There's public, there's private, there's consortium, there's permissionless, there's permissioned. One thing that's important to keep in mind is regardless of the model, blockchain must bring value where it is employed. So regardless of the organization, it must bring value. And because we were talking about the deployment models earlier, I don't know if it's really important to get into these different ones, so I'm just going to go ahead and move on, given the time frame that we're under right now. So blockchain can be used in multiple industries. We've heard Dan talk about it. We've heard Todd talk about it as well. Finance, government, IT, healthcare, education, libraries. But again, blockchain is evolving in how it's used within these different industry types. For my purpose of this discussion, it's really getting into libraries and how blockchain can be used within libraries. So before we start discussing some of the security components of blockchain, it's important to understand the three most crucial components of security. We can do this through the CIA Triad. The CIA Triad consists of three parts: confidentiality, integrity, and availability. So confidentiality is a set of rules that limits access to information. It ensures that information is only available to approved users, where integrity is the assurance that the information is trustworthy and accurate. And availability means that the data or information is available when the users need it. So when we look at employing blockchain from a security perspective, it's important to consider, again, how blockchain can be used to ensure the confidentiality, integrity, and availability of information and information resources. Okay, so there's a lot of information here, but I'm going to try and keep it as short and simple as possible. So blockchain security blockchain offers a number of different security components. The first would be, the distributed network side of it. So data in a blockchain is distributed around many computers that are interlocked. And so for hacking efforts, for them to be successful, more than 50% of the systems in that network will need to be hacked. So at least 51%. So the interlocked computers are going to store the records. So records are stored on these interlocked computers that hold identical information. If one computer's blockchain is updated, or if one computer's blockchain updates are breached, the system will reject it. Again, provided that no more than 50% of the nodes there on this network have been compromised. There is no single point of failure or vulnerability within blockchain. So this is definitely a point that's been argued simply because with blockchain there are a large number of systems or computers that make up this distributed network. And therefore, you're not going to find that single point of failure or vulnerability. There's multi-signature protection. So using more than one key to authorize a transaction process is going to improve security and privacy. And what I'm talking about is public and private key encryption. With regard to with privacy protection, personal data can be seen only with the subject's permission, and the data cannot necessarily be stored. So proof of identity is stored in a cryptographic format, which makes it impossible or very difficult to compromise. And then getting back to encryption, the data, as I mentioned, is fully encrypted. And public and private key cryptography is going to strengthen that security, including identity and access management. Through or with device verification or through blockchain, the use of what Dan had mentioned earlier about smart contracts, devices can communicate securely, and they can exchange value with each other and execute specific types of actions within the network securely. And again, this is going to be based on what is involved with the contract that has been created. And then with secure communication, through the use of public and private key cryptography, data is going to be received by the intended recipient. So how can we use blockchain in libraries? Again, blockchain must in some way or another bring value, and how it brings value to a library may be different than how it brings value to a financial institution or maybe a university or a healthcare organization. But identity management that's everywhere, right? Regardless of the industry that you're in, identity management is going to be important. And through the use of public and private keys, blockchain does help to safeguard private information. With digital assets management, that's another component that blockchain can definitely support. Digital asset management systems do support the management of digital assets through its entire life cycle. And through these systems, we can decide how we want to license, publish, and distribute these assets. These transactions, or the transfer sharing of rights between parties, can all be recorded and executed using smart contracts on a blockchain network. Digital rights management. With digital rights management, it allows creators to register their work with the Copyright Office, which then allows, or with the use of blockchain, to timestamp that work. Creators can then use the system to monitor their work for copyright infringement, and if necessary, they can refer to the timestamp stored in the ledger to show proof of ownership. And again, smart contracts can support this effort. And then connecting libraries and universities. And this is a way to share resources like you would in, say, an online computer library center. So a library center that reaches out globally to numerous users, numerous libraries, and the goal is then to share resources. And again, through smart contracts, we can share those resources and really determine how those resources are going to be used when the contract is up, and then how we dissolve the relation, not necessarily the relationship, but how the asset is then going to be shared within the consortium there. And then community engagement or service, and through the use of blockchain, we can support community-based collections as we would when we're looking at connecting libraries and universities. So with the community engagement or service, we're looking at supporting the community through collections and borrowing through, again, smart contracts. Numerous references for you. And thank you so much for listening, and I'm going to go ahead and pass the mic over to the next person.
Well, thank you, Tonia. Before you get started, Michael, I just want to say I'll put Tonia's references. They'll be available in the recording, but I'll also put them on our website. And I've been taking down everybody's questions. So when Michael's finished, we'll try to get to some of those. So I will just turn it right over to you, Michael, and I will advance the slides if you like.
Okay, thanks, Sue. Actually, I think I might try to do that myself just so I can try to blaze through this. I want to leave some time for questions for everybody. So, hi, everybody. My name's Michael Della Bitta. Thanks for having me here today. I'm the Director of Technology at the Digital Public Library of America, and I'm here today to talk about using blockchains to authenticate and preserve public discourse. Just to get started, there's this meme out there in the non-blockchain focused developer world that blockchains are mainly a storage medium. People understand the general mechanics of them, but they think of them mostly as a cryptographically enabled storage mechanism. And I think The problem with thinking in that way is it leads you down particular paths, and I think these paths to some degree ignore the potential ways blockchains could be put to use to do entirely new things. I'm not saying that these are bad things to consider blockchains for, but I think that there's new stories to tell here. So to add some complexity to our understanding of blockchains, for the purposes of this presentation, I'm going to say that blockchains are just a linked list, where the linked list is a decentralized, live updated, crypto-empowered repository of crucially important data that's collaboratively maintained by a constantly evolving group of international volunteers who are each incentivized to participate. So that's one take on blockchains, and maybe one that's more focused towards cryptocurrency applications. So the new potential value I see in blockchains from that perspective is the way that they align the interests among disparate parties and transactions, rather than in the way they store data, which is more instrumental to how they work rather than the point of them. So if we abstract that out a bit, so to talk about this idea, I just want to take a second to talk about the three major roles in making the Bitcoin network work as an example. There are the actual people or organizations exchanging value in transactions. There are the block miners, and there are the participants verifying transactions and persisting them to the blockchain. So if we abstract that out a little bit, there are miners creating blocks, there's entities seeking to record information to the blockchain, and there's verifiers of that information. So armed with that understanding, the question becomes, how do we plug libraries and other library-adjacent groups into these roles? And before I talk about that, I want to quickly talk about how libraries are currently perceived in civic society, because I think that helps justify the use cases I'm about to outline. There have been numerous polls and white papers posted by Pew Research Center about libraries, and the results are all very encouraging. But to summarize, you can see here that libraries top the list when it comes to who people trust to provide them with information. So I want to talk about two use cases for blockchains that focus on libraries as trusted information sources when it comes to civil discourse. Because generally speaking, we see distrust in civil discourse and public information as a major problem facing the world right now. And we think the evidence suggests that libraries can play a huge role in fixing that. First, a use case on the topic of social media archiving. For good or ill, a lot of civic discourse and even international diplomacy is happening on Twitter right now, and it's becoming an important public record. The traditional approach to archiving this information would be to use the Twitter API, but there's two problems here. One is that the terms of service for that API require us to delete tweets from the archive when the user deletes them from their feed, which is not good for public records. The second is that that archive is unverifiable. In a world where people distrust the source when it conveys the information they don't want to hear, we need a mechanism to prove that the information is actually factual. Sorry, just juggling some windows. So a blockchain approach to this problem might look more like this. Libraries, as a distributed group, record the public record of tweets via observing Twitter's web interface. And validators, who could literally be anyone, cryptographically sign the public record based on real-time observations of the same thing. What we end up with is a very scalable record of what happened on Twitter that's confirmed by outside observers. So here's another use case with a role reversal in the sense that libraries would be playing the validation role rather than the recording role. In the traditional approach to news archiving, we might make periodic crawls of a news site. There's some problems with this, however. A story could be published and then quickly updated several times, which means that if we don't scrape the site quickly, the record of the information misses some of what was reported. This is particularly a problem when the earlier version contains information that was redacted in later versions. The other problem is that any attempt at verifying the information reported is handled in an entirely different venue that has nothing to do with the archive. So a blockchain-enabled approach to news archiving might look more like this. The news-reading public records the news to a blockchain via a browser plugin as they read it. Librarians use the validation role to collectively verify that the record is correct and contains factual information. If the article doesn't check out, they don't sign it. We're left with a public record that captures more information, and it has a built-in mechanism for talking about how truthful it is. Both of these use cases are examples of new ways that libraries could interact with the public to create civic trust. Both take focus on blockchains as distributed data applications that enable new decentralized ways of interaction across institutional boundaries. There are clearly numerous other avenues of exploration along this path. The ground here is newly broken but very fertile. As technologies built with the blockchain or with similar technologies like interplanetary file system and Ethereum mature, it definitely makes sense for libraries to consider them as potential tools as well. And that's what I had today, so I can hand it back to Sue.
Boy, you had so many different topics there, Michael, and it takes a while to all sink in. And I'm just thinking with your use cases, what the future of librarians can be and what they need to do to prepare for some of these things. So thank you all for your presentations today. I have a couple questions that have been in the chat that I will say to everyone, and we can see who wants to answer them. I know that some of the people in the audience are going to be attending the National Blockchain Forum live and doing other sessions in today's presentation. So anyone can chime in or put in the chat. So there had been a discussion, and I think it was pretty much answered, but I will ask it. Do you see a use of blockchain for tracking perpetual rights for journal holdings? Whoever wants to respond to that, please take the mic.
Sure, this is Todd, and this is Anthea. Athena asked this question. I kind of quick answered in the chat. Absolutely. Anytime you have a rights management issue, that could be viewed as, in the same sort of way as a Bitcoin, an object that is exchanged from one person to another. And you can record the rights for having that thing in a blockchain. So that is absolutely a use case. I would see it fitting into a larger system of rights management, but that isn't, again, you could build these systems however you want.
This is Dan. I actually think that there's going to be a token system that you'll see, people being issued tokens that will not only enable them to assert their rights, but it also allows for their authority through consensus building as one of the parts of a consensus-making decision tree. Will be part of that structure with the rights.
Thank you. Let's see. One of the questions was, can blockchain last past a person's lifetime? Is it something that can be included in an estate?
Well, that depends on how you're defining who owns the blockchain itself. If they own the token or some kind of representative aspect of it, say who owns, let's say, a Bitcoin wallet, that has been litigated. And things like that have been described. So it really depends on how you're recording the blockchain and where the evidence of that recording is.
Okay, thank you. I'm going to put the next question in chat so that you can see it. It's, oops. What remedies exist for resolving conflict in authentication amongst the blocks? Anybody like to take that one on?
I can do this one if you want.
Sure.
There's things called ring signatures, which enable every other person has to be on the same page before the next block can be appended. It's kind of a consensus building thing. There's also something called the zero knowledge proof, which is another kind of proof of work mechanism that the computer would engage in order to assert that they can add the next thing. But there's also a thing where it will go ahead and make another block and just fork it off, and they have to decide. They'll go back later and have a consensus after the forks have been built and structured from that fork. Todd, can you elaborate that, or probably say it clearer than I could?
Actually, I think that was fairly clear, and I could probably just make it more complicated. I probably wouldn't help.
Okay, well, I'm going to put another one in the chat. And I've just taken these straight from the chat box from before. So until everyone's IDs are in the blockchain, can I still centralize authentication and authorization for a service that is on a blockchain? Does anyone want to take that on?
It doesn't really require IDs. You can do it on the token basis. So just like you buy a ticket, that would give you the right to engage in the blockchain. And that can be anonymous as well.
Okay. Some of the questions are coming in quickly now, and I don't want to...
Actually, I think this is a different kind of question. So if you are managing a community, and I think this is sort of in a identity management environment, if you are managing a community and say only half of your population, your patrons, were in the blockchain system, there's no reason you couldn't use that blockchain system to authenticate that half of your population that's in the system. I think that's what you mean by this question. It's a little ambiguous. So there's no reason you couldn't use an authorization service for part of your population. In the same sort of way, you could use SAML technology to authenticate part of your community, but not the entire thing. If somebody wants more information, ping me, and I can dig into it in a little bit more detail.
Thank you. I have a question for Michael. Your use cases really got me intrigued. And I was wondering, is DPLA involved, and how are they involved with blockchain and working with other libraries, or is this just a concept at this point?
I think this is just a concept that we're pitching at this point. We're really interested in the blockchain world and in new ways that libraries might work with the general public. So that's what brought us down that path, is talking about this. We do have some friends at IPFS, and there's other places that we're adjacent, but I think at this point we're as new as everybody else is. I think in general, library technology adoption tends to be a little conservative because we have mandates that last hundreds of years. And I remember using a tool to judge how or whether you should adopt a new technology at the time that JPEG 2000 was coming out, and it was suggesting, no, you don't use JPEG 2000. It hasn't been around long enough. So it might mean that for some use cases, these things won't be around for decades until these things are more battle tested.
And the legal world is even more conservative, so it's going to take a while.
There are a couple more questions up here, and I see one that says, must libraries build their own blockchain, or could they build in Ethereum?
So we're at the bottom of the hour. We need to switch to the next sessions.
Okay, that's I've got one more minute on mine, but we will say thank you to all of our panelists, to our participants. The next hour is 8 concurrent sessions going more in depth of case studies of how blockchain is being used or could be used. So I invite all of you to attend one or more of those. And again, these will all be recorded, and come to our blockchain website. And thank you again very much for our expert panel.
Thanks, Sue. Thanks, everybody.